All right, so you've written some code. Awesome. But now what? How do you get that application off of your laptop and onto the internet so that anyone, anywhere can use it? Well, today we're going to pull back the curtain on that whole process. We are going on a journey to create your very first server, starting with a few simple clicks and leveling up to some really powerful code.
Right, so your app is running perfectly on your laptop. But let's be real, you can't just leave your laptop open and connected to the internet forever, right? It's not designed to handle tons of users. What you need is a computer that is powerful, always on, and always connected. You need a server. But the word server itself, it's kind of changed over the years.
Back in the day, if you wanted a server, you literally had to go out and buy a big, heavy, expensive box, a single physical machine for a single purpose. And it was super inefficient. Most of the time, you were only using a tiny fraction of its power. But that's not how we do it anymore. The game changer? Virtualization. We take one of those giant physical servers and we digitally slice it up into lots of smaller, totally isolated virtual servers.
And the magic that makes this all possible is a special piece of software called a hypervisor. Think of the hypervisor as like the ultimate landlord for a computer. It owns this big building, the physical server, and its job is to carve it up into a bunch of little separate apartments or virtual machines. Each VM has its own walls, its own front door. It thinks it's a completely separate computer, even though they're all sharing the same foundation. So how does this all work? It's actually pretty simple when you break it down. Step one, you've got the hardware, the actual physical server. We call that bare metal. Then you install the hypervisor software right on top of it. And from there, you can start creating or spinning up as many virtual machines as you need. When you go to a cloud provider like AWS or Azure and ask for a server, this is exactly what's happening behind the scenes. They're just handing you the keys to one of these virtual apartments. Okay, so here's the plan for today. First, we're going to walk through the manual way, the point-and-click method that almost everyone starts with. Then we'll talk about the problems you run into with that. After that, we are going to unlock the much, much better way, the automated approach, using something called infrastructure as code. And finally, we'll talk about your path forward.
All right, let's dive right in. The most common, the most popular way to start is just by logging into your cloud provider's website, their web console, and you just start clicking. It's super visual, it's interactive, and honestly, it's a fantastic way to learn the basics. So what does that look like? Well, first, you'll pick an operating system. Ubuntu is a super common one. Next, you choose an instance type, which is just a fancy way of saying how much power you want, how much CPU and memory. Something like a T2.micro is perfect, and often free when you're just getting started. You'll set up some basic networking, create a special security key so only you can log in, and then you hit that big, beautiful launch button. So you hit launch and boom, your server is running. But, and this is a big but, you're not done. Not even close. You see, the operating system you just installed might be a few days or even a few weeks out of date. The absolute first thing you have to do every single time is connect to it and get it updated. So you use that security key you got earlier to log in. Once you're inside, you run a simple command, sudo apt update. What's that do? It just tells your server to go check for all the latest software updates and security patches. Super important. Once that's done, you're ready to install whatever your app needs. Maybe something like Git to download your code. Okay, that wasn't so bad, right? A few clicks, a few commands, and you have a server up and running. And honestly, this is great for your first one, or maybe your second. But this is where people hit a wall, a really big wall. Think about it. What happens when your team needs, say, 10 of these servers, and they all have to be identical for testing? Or what if your app gets popular and you suddenly need 100 of them to handle all the users? Are you really going to sit there and click through that whole process 100 times? No way. It just doesn't work. This, my friends, is the manual trap. It's slow, it's boring, and it's so easy to make a mistake. Did I pick the same server size on number 57 as I did on number 12? Who knows? This leads to these little inconsistencies between your servers, which causes all sorts of weird bugs. And maybe the worst part? There's no paper trail. 6 months from now, nobody has any idea how that server was actually set up. So, how do we get out of this mess? Simple. We start treating our infrastructure, our servers, our networks, everything,
the same way we treat our application. We define it with code. This is the big idea behind a practice called infrastructure as code. What does that even mean? It just means instead of clicking buttons in a web browser, you write down what you want in a simple text file. You literally write, I want one Ubuntu server this size with these settings. Then a special tool reads that file and automatically builds exactly what you described. And honestly, the difference is like night and day. The manual way relies on you remembering every single step perfectly. It's fragile, it's human. The automated way, it uses code, a file. That file is repeatable. Run it 100 times, you get 100 identical servers. It's version controlled, so you can track every change in Get, and it is incredibly fast. And look, don't let the word code freak you out. Most of the time, it looks something like this. This is just a text file, in this case, a format called JSON, that's just describing what you want. You can see it says the resource type is a virtual machine, and the image it should use is Ubuntu. It's descriptive, not some complex algorithm.
Okay, so the code we just saw works for one cloud provider, Azure. But what if you're using AWS or Google Cloud or all of them? This is where a tool like Terraform becomes a real game changer. It gives you one consistent way to define your infrastructure no matter which cloud provider you're using. You learn one tool you can build anywhere.
Okay, so we've seen the two worlds, right? The world of clicks and the world of code. And the thing is, it's not about one being good and one being bad. It's about using the right tool for the right job. Let's just break it down one last time. That manual point-and-click method, it's awesome for learning. It's perfect for your very first server when you're just exploring. But it's slow, and it doesn't scale. But infrastructure as code, that's built for the real world, for production, for teams, for doing things over and over again. It's fast, it's consistent, and it can scale to whatever you need. So here's what I want you to take away from all this. Start with the clicks. Absolutely. It's the best way to understand all the pieces. But as soon as you find yourself doing the same thing twice, start thinking about code. Think of it this way. Your first server is just a click away, but your 100th server, that's a command away. And that is how you build something real.